Hello, thank you for taking time from your day to join us for this webinar. My name is Carol Rawson and I serve as the chairperson for the Dystonia Advocacy Network, also known as the DAN. I also serve as Vice President of Public Policy for the Dystonia Medical Research Foundation, or the DMRF, and it's my pleasure to welcome you here today. The DAN is a collaborative effort of the Benign Essential Blepharospasm Research Foundation, the Dystonia Medical Research Foundation, the National Spasmodic Dysphonia Association, and the National Spasmodic Torticollis Association. All organizations working together for 15 years to advocate for all persons affected by dystonia. I want to thank all of our advocates who are joining us tonight for this program. We're excited to share this information with everyone, but especially to share it with our advocates, because their efforts to get dystonia included in the list of eligible conditions with the US Department of Defense Peer Review Medical Research Program allows dystonia researchers, like our speaker tonight, to compete for funding. If dystonia is not on the list, researchers like Dr. Peterson can't apply for funding. So thank you all so very much for helping to make these opportunities for funding available. Dystonia has been on the list since 2010, and since then, dystonia researchers have received more than $17 million in support for their work. We know this is awesome. We know this is a very competitive program and that really good science prevails. We also know that dystonia advocacy works because in November of 2020, the preliminary list for the DoD Peer Review Medical Research Program was released and dystonia was not included. We took immediate action and worked very hard for 3 weeks. The final list was released in December and it included dystonia. Dystonia was the only medical condition added last year, and we all made that happen. And I want to thank all of you who were part of that effort. Your voice is heard and it makes a difference. Congratulations and thank you for all that tremendous effort. I want to also acknowledge the support that Dan has received from Allergan, an AbbVie company, for our work this year. Before we get started, I have just a few announcements. This program is being recorded and we will get the link out to everyone and all DAN organizations. Everyone but speakers will be muted just because of the number of participants. If you have questions, please use the question function and we will get to as many questions as we can. Please limit those questions to the presentation tonight. Thank you to those of you who already sent in questions. We will take questions at the end and they will be moderated by Janet Highshetter, staff to the DAN and executive director of the DMRF. I want to thank the DMRF for hosting this webinar and Jody Roosevelt for her efforts in arranging the webinar and for her technical assistance. Speaking of which, if you have any technical difficulties during the webinar, please email Jody Roosevelt at jroosevelt@dystonia-foundation.org, and she will do her best to assist you. So now on to our program. It is a pleasure to introduce our speaker tonight. Dr. David Peterson is a project scientist in the Institute for Neural Computation at the University of California, San Diego, and the Computational Neurobiology Laboratory at the Salk Institute for Biological Studies. The primary focus of his research is adult onset focal dystonia. Dr. Peterson received his PhD in computer science with an emphasis in neurosciences from Colorado State University. He serves on the executive committee of the Dystonia Coalition and is co-chair for the Dystonia Medical Research Foundation's Brain Networks meeting scheduled for the fall. Please, again, limit your questions to the presentation tonight, which will be answered at the end of the program. Dr. Peterson received funding from the DoD Peer Review Medical Research Program, and we are very much looking forward to hearing about that project. Welcome, and I turn this over now, Dr. Peterson. Thank you all.
Okay, thank you, Carol, and thank you for the introduction. And thank you, Janet and Jody, for inviting me to give this presentation and for arranging this evening's session. I've been looking forward to this for a couple of months now since Janet invited me, and it's not often that scientists get an opportunity to talk with a broader audience beyond other scientists about their research, and it's always a pleasure. So thank you, everyone, for joining in. There, as Carol alluded to, a whole host of dystonia research that the DoD has funded over the past several years, and this project I'm going to talk about tonight is but one of those. I would talk about many other scientists' work, but I wouldn't feel as qualified to talk about their work as I would about mine. So this will be focused just on our project this evening. And the focus of our project has been to come up with ways to measure the motor symptoms we see in dystonia, in particular cervical dystonia, that are truly objective. And I'll explain why that is significant and important. But before I dive into some of the science elements, I want to paint a broader picture of the different organizations that sponsor dystonia research. The only way we're going to get to better care for patients is really through research, and everyone can appreciate that. The question is, how does that get done? And there are a number of ways. There's foundations, and of course, the National Institutes of Health, with whom many of you have become much more familiar through the pandemic the past year and a couple months. And I don't have all of them listed here, but among the foundations, of course, the DMRF, the BEBRF for blepharospasm, the National Spasmodic Dystonia Association. There used to be the Bachman-Strauss Dystonia Parkinson Foundation that would fund some dystonia research. And these groups provide a very critical role in the landscape of the link between patients and sponsoring research. And even though their budgets aren't typically as large as federal organizations, they're very critical in funding early stage and smaller projects that provide important preliminary data to provide a solid, compelling rationale for larger grants from federal agencies. And then the National Institutes of Health, it's plural because there's about 30 plus institutes within the NIH. NIAID for allergy and infectious diseases, you're all familiar with COVID. But the institutes that are involved in dystonia research are primarily the National Institutes of Neurological Disorders and Stroke, where Mark Hallett works at their internal labs. I think you heard from him in one of your past sessions along these lines. And also the National Institutes of Health has a Center for Advancing Translational Sciences, and they played a critical role I'll mention again later. But there's also the Department of Defense, and in particular, the Congressionally Directed Medical Research Program. The Department of Defense is notorious for having a lot of acronyms, and these programs are no exception. So the important thing here is that it's medical research, and a lot of people don't realize that the Department of Defense, more broadly speaking, sponsors a very large proportion of the biomedical research in this country. And this program in particular, being congressionally directed, means that that list of disorders for which applications are eligible for this program, including dystonia, that list is revisited each year by Congress. And so the work of the advocates that Carol brought up earlier is critically important to maintaining dystonia on the radar for this program. It also goes by another name, the Peer-Reviewed Medical Research Program, PR. And that's an important concept because applications are competitively reviewed in a process that is very similar, not identical, but very similar to that used at NIH, where our scientific peers critically review applications for merit in a number of regards. And although there's some differences between the Department of Defense and NIH, they both have very rigorous programs for review. One interesting aspect of the DoD's program in this regard is that they include what's called a consumer reviewer. And that's an important difference where someone from the lay public that may have a particular interest in the disorder and some knowledge, but not the same scientific training per se, can provide a very complementary perspective on reviewing the merit and rationale for applications. I've listed here the email address and the web address for dystonia advocacy that Carol provided. So you might want to make a note of these if you have questions, want to help participate, or register for this year's Advocacy Day. And thanks again. We couldn't do this research without your help. So the specific project I'm talking about tonight on cervical dystonia was awarded as what's called an Investigator-Initiated Research Award. And there's a couple of versions of it. One version is called it's a partnering PI. PI stands for Principal Investigator option. And the basic mechanism is there's two investigators, usually two different institutions, that play a critical role in moving the science forward. And I was here at UCSD, was the lead PI on this, and the partnering PI has been Cindy Camella and Skip Stebbins at Rush, who have been such a delight to work with, and we've had a lot of fun with this project, and we just had another fun call this morning, as a matter of fact. So why do we want to, what are we doing, and why do we want to do it? The goal simply is to measure motor symptoms and their severity. Are they mild or severe, and various gradations in between? And the overall approach with this is to come up with and develop software and algorithms that can recognize and quantify motor abnormalities from conventional video recordings. So in many neurology clinics, especially with the movement disorders focus, it's not uncommon, especially if they're involved in research, for them to have video cameras and take video recordings of patients with your permission, of course, and written consent to review. And in scientific meetings and in clinical meetings among neurologists, it's very common. It's kind of the modus operandi, if you will, to review videos of patients and discuss what you see. It's very much a visual art. We're trying to bring some objective quantitative rigor to supplement that expertise. And the basic idea is, if we come up with measures, do those measures agree with what the clinicians would assess in terms of the rating of the severity? And that's kind of the first test of validity of these methods. You might step back and say, well, why are we focusing on motor symptoms? There's a growing appreciation for a lot of other non-motor aspects of dystonia. And certainly those exist and are critically important. But motor severity can have an effect not just directly on quality of life, but also on aspects of impact on activities of daily living, and especially for cervical dystonia, things like pain, which many patients suffer with. And then why are we focusing in particular on severity? Oftentimes, the computational people are brought in to see if you can do diagnosis or screening. Our focus has been on severity for a number of reasons. It's important for basic research into what's going on in the brain and the underlying genetics that are related to or may play a causal role in some forms of dystonia. Measuring severity is important for tracking how the disorder changes over time, even within individual patients, whether there's progression or spread, and not just in terms of its presence, but its severity. But perhaps most important, really at the bottom here, is the impact and the role in clinical trials. So if we want to come up with new treatments and test them, we need to see, does the treatment help? Does it reduce the severity? And so there's a simple, we look at what the severity is after the treatment and compare that to the severity before and see if it increased or decreased. And this is important regardless of the treatments. Many of you get periodic botulinum toxin injections, but there's some of you that benefit from deep brain stimulation. There's also research into new oral medications and more experimental methods that are things like repetitive transcranial magnetic stimulation. But across all these measures of severity are critical. Now, how is severity currently measured? What's the current state of the art? As I alluded to before, movement disorders is very much a visual art, and it's from observation by a clinician who's usually an expert in movement disorders and often experienced with many dystonia patients. And it's quantified usually in what's called an ordinal scale, where you assign round numbers to the severities. 0 if there's nothing present, 1 if it's mild, 2 if it's moderate, or 3 if it's severe, as an example. And an important concept here is that these are intrinsically subjective. They're based on human judgment. And no matter how good that is, it's susceptible to a number of problems, including variability from one assessment to the next. If I give a clinician a video of a patient a year from now, they might quantify it a little bit differently than they would today, even if it was the same video. or if I give the same video to 5 different doctors, they might not all agree on what the severity rating should be. So there's this concern about, variability, and not that it's not so much a question of accuracy as much as consistency. And that variability plays an important role when we're trying to assess treatments in clinical trials. There's some natural variability as a result of the treatment over time or from one patient to the next. But if we add to that variability in our measurement, then our total measured treatment outcome variability can dilute the results of any given treatment. And there might be things that are effective that don't look effective with these measures, or vice versa. And we really want to know which treatments are most helpful. Just as an example, outside the scope of cervical dystonia, folks that suffer from dystonia in the hand or upper limb, the arm, especially in musicians' dystonia, have been studied with a number of these different rating scales. And we did a review several years ago of the number of studies that have been done across a number of different types of rating scales. The overwhelming majority of those were subjective, either assessments by the patient themselves or by the clinician, and a relative minority were objective. And this is the case across most neurologic disorders, especially movement disorders, and especially dystonia. So there are a number of ways of getting objective measures of severity. Why use video instead of things like measuring movement by putting specialized markers and equipment on the head, for example, or using ways to measure the muscle activity with electromyography or EMG? The value of video comes in many forms. One is that it has minimal additional resource requirements. If the clinic already has video, they don't need to get out the EMG equipment, or they don't need to acquire specialized equipment for measuring movement in space. And they don't need the expertise, and they don't need to allocate the additional time to do those. They can take a video recording during a standard clinical examination, and we can use that. And like I said before, video cameras are pervasive in movement disorders clinics. Another important thing, somewhat specific to many movement disorders, especially dystonia, is that the placement of things on the head can, in some cases, alter the dystonia itself. Some of you with cervical dystonia might be familiar with so-called sensory tricks, where your abnormal head posture can be temporarily alleviated with touching part of the head. So the concern is if we're putting devices on your head to measure your head orientation, that might affect the very thing we're trying to measure. And then there's an obvious potential future extension to telemedicine. Everyone's walking around with their cell phones, and cell phones all have video cameras these days. So with the appropriate authentication and authorization and consent process and secure video transmission process in place, you can easily envision how these technologies could be fielded where we can measure your dystonia severity, not just once every 3 months when you're in the clinic, but every week or every day or throughout the day, and come up with measures that more accurately reflect the severity of your measures in your daily life at home and at work. So I'm going to walk through a handful of results that we've come up with over the past few years with a number of students on my team. And the basic idea here is capturing head posture is simple as looking at how the head is rotated in each of 3 axes of rotation depicted here in the lower right. So with modern computer vision methods and algorithms, you can take a standard image from a video recording, and you can identify where the face is, and also they can estimate the orientation of the head in space. And we've been looking at this with a population of roughly 200 patients through the Dystonia Coalition and a number of collaborating centers that had collected data, very detailed data, including video recordings, but also detailed clinical data on some of these patients. And we've looked at the distribution of across different patients of how their head is oriented in different directions. Some doctors have hypothesized, for example, that more patients tend to turn left than right. And here we've got real quantitative, objectively acquired data to begin to answer these questions. But one of the more important questions really is, with our system, we call it CMOR for Computational Motor Objective Rater. It's just a name for our system. The question is, does this computational video-based system give us assessments of severity that agree with the doctor? This is the test of validity I mentioned before. And in each of the three ways that you could tilt your head or turn your head, the doctor's ratings are on the x-axis here, and Seymour's estimates of the rotation of the head in the different axes are on the y-axis. There's a positive and significant correlation between the doctor's ratings and what Seymour predicts. So the answer here is yes, at a crude level, Seymour does agree with the doctor for head posture. What about a number of you are familiar with, you might have a restricted range of motion. If your head typically is turned one way, you may not be able to turn it the other way as far as you would if you didn't have dystonia. So how do we go about quantifying that? We've used Seymour to do that, and here we're just showing a couple of the axes in which the head can turn. And to briefly go over these plots, how far you can turn your head left or right, or tilt it left or right, is depicted here. And the y-axis is how many different patients can turn it that far. And these black curves give a summary of that information. And the vertical bars here are depicting what the average range of motion is for either older or younger adults that do not have cervical dystonia. And you see here that tilting the head range of motion overall is diminished only slightly, but the biggest difference really here is how far you can turn your head left or right, the yaw axis. But here we've got some quantitative information on that really hasn't been captured before with this many patients. And again, with the range of motion, our estimates bear some relationship that's statistically significant with what the clinicians use to measure range of motion. In this case, the clinical rating scale, 4 is more severe, so you have less range of motion, and that's why the slope here is negative. With a couple of other students, we've also been looking at head tremor and cervical dystonia. So many of you experience repetitive movements of the head, and it has various forms, but this can be, it's very visually obvious to people around you, and it can be very disabling and has a big impact on social aspects of quality of life. So how do we capture this? Of course, with video, we've got information in time, so we should be able to look at this. And this is just a brief video depicting a model of the head that is being rotated based on Seymour's estimates of head tremor in this patient whose identity is blurred out here for confidentiality purposes. And you'll see over time here that the model head is rotating and exhibiting head tremor in a fashion similar to what the patient's doing. So this is an important kind of a visual insight into otherwise what is just a bunch of numbers in some of our analyses. So if we take Seymour's estimates of the strength or the severity of tremor and see how those compare with the clinical ratings, here again, they show a significant positive correlation, suggesting that we can use this method to really quantify the severity of your head tremor. We've also looked at this question of different types of head tremor. So not everyone's head tremor is the same, not only in terms of gradations of severity, but its qualitative characteristics. And this has been the topic of much discussion in the movement disorders field about what we call these things and how they're defined, and not everyone agrees with everyone else about how they're defined. But as some backdrop, what we did is we wanted to look at the relationship between head tremor, which is quite common in cervical dystonia, and also pain, which is a common debilitating feature of cervical dystonia. And clinically, the doctors have attempted to distinguish two different types of head tremor, a type that's jerky and a type that's quote unquote regular or smoother. And related efforts in another movement disorders field of essential tremor, they've tried to come up with similar definitions and distinctions. And to give you a sense of the difficulty of this and how much of a central role it plays in neurology, it took them several years to come up with even the definitions. But here's one example of why this is important. In our set of about 200 patients, if you wanted to look at the relationship between pain, severity on the y-axis here, and how severe their tremor is, for the folks that had jerky head tremor, their tremor severity did not really play a role in how severe their pain was. But in contrast, for the regular head tremor patients, the more severe their tremor was, the more severe was their pain. even though the two groups didn't differ in terms of average levels of pain or tremor severity. So this and many other things, including understanding the underlying brain mechanisms, really motivates the question of how can we, can we distinguish between these head tremor types with some objective tool? So with a couple of additional students, we've been looking at this for the past couple of years and have had some striking breakthroughs literally just in the past couple of weeks. So here we're not trying to see if there's a relationship between the clinician's assessment of severity and our assessment of severity. Here we're trying to see if we can distinguish between regular and jerky as well as or consistent with the doctor's distinction. And there's a number of ways of quantifying how well one can make that distinction. And the common one is through a method. I won't go into the details, but basically you can depict graphically how well you can distinguish things with a curve. And how far that curve deviates from this diagonal line gives you a quantitative assessment of how well you're distinguishing between the two groups. And this is quantified by the area under this curve. And the length of both of these axes is 1. So if we had the entire area of this square, it would be 1. So that this area under the curve is always a value between 0 and 1. And so we have an area under this curve of almost 0.97, which I've worked with a lot of problem domains. I was very excited when I saw this result because you don't see results this good very often. So I'm very excited about these results. And the preliminary evidence here suggests that we can distinguish between these types of head tremor objectively. Another common feature I alluded to before in cervical dystonia, the sensory trick. It's interesting to look at because it might give us insights into the brain mechanisms. But if we can quantify how much it helps, it might also provide some groundwork for seeing if our methods are sensitive to treatment effects, how much better you might get with a treatment that has a more persistent difference in your cervical dystonia. Here's a patient who's been used in previous training videos for the Twisters rating scale that the doctors use. And here's a couple of frames taken sequentially different points of time in the video. And here you're seeing how the deviation from 0, which is centered, normalizes over time as he executes this sensory trick. So the question is, before we look at this with Seymour, we had clinical data on these sensory trick effectiveness ratings from multiple doctors. And when I first looked at this raw data, I was really awestruck. Literally the first patient in this long table showed 5 different doctors' scores for the patient, and they couldn't have been more different. 3 of the doctors considered a score of 4, and 2 of them gave it a score of 0. So I was a little bit awestruck when I saw this and concerned if we're going to be trying to develop a method based on these doctors' assessments, we first need to dig a little deeper into the doctors' assessments. So this is a paper we just published last year where we dug into the data carefully and found that for detailed technical reasons I won't go into today, if you look at the way that the doctors rating the sensory trick related to overall measure of severity for the patients, most of the doctors, there was about a dozen or so different doctors here, most of them rated it in the same way. One showed a markedly different pattern. The details here are unimportant. The take-home message is that sometimes, despite the best of efforts and even a lot of training and experience, the complexity of some of these clinical rating scales, especially about something like the sensory trick, can lead to cases where doctors accidentally rate things the wrong direction. This isn't so much a knock against the doctor per se, it's really a concern about the challenge of trying to do all these rating scales in a consistent and efficient fashion. So can we circumvent this and help the doctors by providing a method that's objective? And so with one of my students, we've been working on this for the past couple of years, and she's got some preliminary but very encouraging results that with Seymour, we can detect how much your symptoms improve with the sensory trick in a fashion that's consistent with the doctor's ratings. And this was using a single doctor who did them all correctly. And then just a little, another sign of encouragement that we might be able to accurately assess the beneficial effects of treatment. Here's a little depiction of how a person's head deviation from 0 changes over time in each of the 3 directions of rotation before they got their Botox injections. This must have been at the end of their cycle, at least a few months after their previous injection. And then here's what it looked like after their injections. Now, of course, not all cases respond this well, but here you can, very clearly, markedly see the reduction in the head movements over even just a handful of seconds after treatment. So that paints a picture for you of kind of some of the scientific details of what we've been doing and illustrations that we're very excited, because it looks like in a number of different ways we can objectively capture many features of the motor features of cervical dystonia. So I wanted, before we pivot to a Q&A session, I wanted to paint a little bit broader picture here and remind you that there's not only, of course, the NIH, but the Dystonia Coalition, who I don't know if Janet referred to, but I referred to earlier. It's a large organization that really is an umbrella for many different things, including all the patient advocacy groups, some of the foundations I mentioned before, as well as a number of people at NIH who participate, and a large number of dystonia researchers and centers, not only from North America, but several other countries around the world. And thanks to some funding from NIH and these 2 specific institutes, the Dystonia Coalition has been an ongoing enterprise for, I think, the past 10 years. It's in its 11th or 12th year now. And so we are continuing much of this work in cervical dystonia. And we, with support from NIH and the Dystonia Coalition, we are taking these multiple measures of cervical dystonia severity, and we will combine them into a broad single measure of motor severity for cervical dystonia that we hope to be useful for future clinical trials. But under the auspices of the Dystonia Coalition, we're also expanding our scope into blepharospasm, which in fact is where all of this started. We did one of the first video-based objective assessments of blepharospasm and reported it in the paper 5 years ago, thanks to support from the DEBRF. But we're going to expand that to look more carefully at some of the specific features of blepharospasm, like excessive blinking and spasms. We also have a project underway, have had for the past year and a half, on spasmodic dysphonia, or laryngeal dystonia. And the question is, can we distinguish between the AD, adductor, or AV, abductor forms of spasmodic dysphonia, or can we identify voice tremor? But here again, also, can we quantify somehow severity from videos of the larynx that some of the ENT docs take? I also want to remind folks that even though much of the emphasis here is on measuring severity for purposes of clinical trials, myself and many other scientists are also very much interested in the basic science parts of this and what's going on in the brain. And if we can figure out those circuits and the circuit activity better, we can come up with treatments really directed more at the causes than at the symptoms. But that's a tall order. But the important thing here is that with these kinds of precise objective measures of the symptoms that have more temporal precision over time and can be looked at more frequently over time in a patient's day-to-day setting, if that information could be used and combined with a lot of the more detailed advances in genetics, we might be able to triangulate and better constrain models of the brain circuit pathology that's going on in dystonia. That's one of my long-term views. And then there's the question of what is the relationship between not only clinicians' ratings and the patient's assessments of their own severity, but also what about the patient's assessments of their severity relative to these objective measures? And there again, we might be able to better triangulate what's really going on with the disorder. And as I alluded to before, really this plants the seeds. If we're using conventional video recordings to construct these measures, it could easily, well, not easily, but it's an engineering enterprise that is doable to put this on phones or tablets or computers and make it a mobile implementation that's supportive of telemedicine. And the importance of that and significance of that for access has been, made much more vivid this past year with many of us seeing doctors through something like Zoom or phone calls. I just want to acknowledge, and many folks here are missing from this picture, but I've got a lot of students on our team that really contribute to a lot of this work with a lot of enthusiasm. And I'm also surreptitiously trying to get the next generation enthusiastic about movement disorders research and hopefully dystonia. And there's countless number of collaborators, many of whom actually aren't listed on here, and many of the institutions and organizations I alluded to earlier that really have supported our research, for which we're all very grateful. And again, I want to thank the advocates for the work you've done to ensure to try to keep dystonia on the radar for the CDMRP. So with that, I wanted to wrap up, and I put here the email address and the website again for the Advocacy Network and Advocacy Day. So thanks everyone for your time. I really appreciate it. And Janet, I guess you're going to field questions, right?
I am. Thank you very much for sharing your work with us. This is it's very cool. And I know advocates appreciate the opportunity to learn more about, what their work resulted in. So thank you. And congratulations, because I know this is a very competitive process. And so congratulations on having received this award and putting it to good use. So we have a number of questions. Now, some of them are a little bit more medically focused, and we can respond to those folks offline. But we had one question about, are there advancements in studying the brain accompanying the stress with dystonia being made? So is CMOR something that could also be used to study factors that we know might make dystonia worse? Like stress?
That's a good question. Things that are not overtly obvious and visually obvious on the face and the head are not really in the purview of what CMOR is designed to do. It's really based on what a video could capture in the head and the face. Having said that, one of its earliest applications, and by some of my predecessors, was to look at facial expressions of pain. That pain isn't always evident on the face, but if there's acute and substantial pain, sometimes it is. And so people have validated the application of CMOR's predecessors for things like pain. But I think to the question, the broader topic of stress, it's only very indirect. Okay,
great. You mentioned that this program has a consumer reviewer component to it. Can you address how people become consumer reviewers?
That's a great question. And I have to apologize, I have no idea.
Well, I might be able to help you out there.
Good.
So if someone is interested in becoming a consumer reviewer, we're happy to hear from you. You need to be nominated, and there's a process that you go through. There are, I'm sure, a number of people tuning in tonight who have served in that role. So thank you for your service as a consumer reviewer. It is a really important part of this review process. It's an intensive kind of 6-week period where you're asked to participate in the actual reviews. So you're working with scientists, but there is a lot of weight given to consumers' views on the importance of projects that are proposed for funding. So if you're interested, you can respond to the email address here, and we'll get you connected there. So thank you for that question. So another question about, and you touched on this a little bit, but could CMOR be used potentially on the videos that patients often take? Because, when patients are in an exam room, sometimes their symptoms may be worse or less worse than they are when they're at home. And oftentimes they videotape themselves to show their physicians sort of what's going on. So could this potentially be used with those selfie videos?
Yeah, absolutely. Ultimately, there's no reason why not. And we have been doing testing on things like how robust is it for suboptimal lighting, or if the camera's being held in the hand and if it's not being being recorded on a tripod, things like that. And to a large degree, most of those things it's robust to. So there's still some open road in terms of the engineering that would be required to take us from a research tool to a tool that is what I call fielded on a platform that someone could use. Some of it's the technical part, much of it's the data security part, but that's very much on the radar. It's probably just at least a few years away.
Okay, we've got a couple of questions that are sort of connected. So could CMOR be used with something like a post-stroke dystonia in the hand and foot that isn't writer's cramp, or could it be used in other movement disorders like Parkinson's disease, or even something like cerebral palsy?
Yeah, great question. So there are a number of other technologies out there that have been developed that are video-based that capture movements of many other parts of the body below the neck, whether it's the upper limbs or lower limbs or what have you. And that is not the purview of Seymour currently. We're focused on the stuff from the neck up for a number of reasons. But there's complementary technologies that do those other things that would be relevant for cerebral palsy and the focal hand dystonia. What I envision in the long term is that a lot of these things will be melded together, where you'll have one solution with a single video recording, where these various technologies could be brought together and integrated to look at all of these things from one video. But again, that's a ways off.
Yeah, yeah. Well, it's good to have these things to look forward to, right? So.
Yeah.
So a question, could clinicians utilize a calibration session regularly to ensure more objective measurements of movement in their visual assessments?
That's a great question, and implicitly a great suggestion. And to have a frequently used calibration procedure, even for the subjective rating scales the clinicians use, I think would be useful and helpful and probably increase their consistency. It would certainly have a time demand, and it wouldn't be clear how often someone would have to recalibrate. But I think that would be useful. To my knowledge, such a process is not widely used. I may be missing examples, but I don't think it is. And an important thing to keep in mind is we have to be really careful about clinicians' time. That's definitely a limited resource, and so if there's time taken away for calibration processes, although it might improve ratings, it's time taken away from patients. And so that's one of the main motivations for developing complementary objective technologies like this, is really to free up clinicians' time to optimize their expertise for other things and for more patients.
But there could be utility for something like this in training a physician on how to do rating scales, correct?
Yeah, absolutely. So maybe you're alluding to a different situation where we're using these objective methods either to do the calibration or training. And that's a different interpretation of the question. Yeah, sure. Absolutely. And that was one of the first things that came to mind when we found, in the case of the sensory trick, where accidentally one of the doctors must have been rating things backwards. The obvious thing that came to mind is, well, we should be able to catch that then with a complementary objective tool, and to guide them, therefore, to revisit how they're doing things. Yeah.
How close to open distribution of Seymour is for clinicians to actually use?
Good question. I think for the cervical dystonia stuff, this is like predicting when vaccines will be ready. Back in March last year. I don't know. I would guess 2 years, plus or minus 6 months. I think that's a tractable goal for at least the cervical dystonia part of it.
That's actually sooner than I would have thought. So that's great news.
Don't hold me to it.
Well, you're being recorded, so we might.
Right. We'll revisit this 2 years from now.
Yeah, exactly. So we have a question from someone who actually was a volunteer to be videotaped for the Dystonia Coalition. So yeah, exactly. Thank you very much for doing that. And they're wondering if their video might have been one of the ones that you use. Can you just explain that sort of the pool of resources through the coalition, maybe?
Yeah, sure. So many of you are familiar with the Dystonia Coalition. One of the things one could spend a whole hour or more just talking about the Dystonia Coalition. But one of their important activities, of course, is recruiting patients into studies. And it's an ongoing thing. And if you're interested in helping the research mission, I strongly suggest that you reach out to your physician to see if they're involved in the Dystonia Coalition and how you might be able to help. And those research studies are pulling data from on the order of thousands of dystonia patients. Like I said, across the world, predominantly in North America, but from many countries around the world. And studies like this one that I just talked through tonight would never have been possible without the Dystonia Coalition. So if you can imagine, if I was trying to analyze 10 different dystonia patients from each of 20 different centers, instead of one organization like the Dystonia Coalition that brings together all that data in one place, I would spend 90% of my time doing bureaucracy and 10% of my time doing the actual research. So it is a godsend for people that really want to analyze the data and try to come up with better tools like this. And I'm not alone. There's many other folks and probably hundreds of papers that have been published that have come out of the Dystonia Coalition that simply would not have been possible any other way.
You talked a little bit about the connection between CMOR and genetics. Can you expound on that a little bit?
Yeah, so throughout many different brain disorders, not only in neurology, but even in psychiatry, there's been a big push over the past decade to try to see, start to look at relationships between the genetics and that's a very low level, right? That determines what molecules and proteins are produced in billions of neurons in your brain and how they're organized and how they interact. We're trying to look, we need to bridge a big gulf between that knowledge and the rapid expansion of knowledge about genetics and what's going on at the level of the whole brain and what's visible for the whole person on the outside in terms of their motor symptoms. There's a huge gulf there. And the sophistication of our knowledge about the genetics is improving much more rapidly, ironically, than our sophistication in terms of measuring the symptoms of what we see, what's sometimes called the phenotype. And so for the purposes of the basic research and bridging that gulf between us to try to understand what's going on wrong in the brain, we really need to get a much more rigorous, quantitative, and more precise handle on the symptoms, because those can be used to constrain models of the brain circuits that underlie what's going on with the muscles in your body.
Yeah. So is this method applicable only to cervical dystonia? You talked a little bit about where you're going from here. Can you just talk about that a little bit more?
Sure. So a couple things. First, when I say cervical dystonia, I mean patients with cervical dystonia, and it may not be limited to cervical dystonia. For patients that have segmental dystonia or even generalized dystonia patients that have some effect on head posture, this is relevant for that. So people with cervical dystonia, with or without other things. The work we're doing on blepharospasm that we have done and that we're restarting now through the Dystonia Coalition obviously is relevant for patients with blepharospasm, regardless of whether or not they also have cervical dystonia and dystonia affecting the rest of the body. The stuff we were doing with videos for laryngeal dystonia, it's a different beast because it's not video of the face and the head, it's a video of the larynx taken from a scope put down your throat for laryngeal examinations. But the underlying algorithmic aspects are similar. So if you look at the distribution of different types of dystonia in the body regions affected, the face, the head, the neck, and the throat cover a large portion of them. And there's plenty of researchers, like I alluded to before, that are focusing on technologies that look at the limbs, upper limbs or lower limbs.
Yeah.
So we're really trying to fill a gap there in terms of the body regions affected, and it happens to map nicely to what we see in dystonia.
Yeah, thanks. Here's an interesting question. Do you think that this research will eventually help physicians determine the appropriate dosing for botulinum neurotoxin treatments of the dystonias?
Great question, and it's not simple. I think that there's a lot of good rules of thumb that experienced practitioners already use in terms of toxin dosings. However, my impression, and it's just that, has always been that there's room for optimization there. And if we have an algorithmic objective basis for doing that, then that would really help a broader spectrum of neurologists be able to do optimal treatments of dystonia. So many folks, depending on what kind of practitioners are available in their specific geographic region, might think one person's injections are better than another's, and maybe depends on their experience, how many people they inject per day, et cetera. If we can help expand access to a broader cohort of neurologists that would have additional tools to help them optimize their treatments, that would be a real win. But I don't think that's trivial, and I think that's a doable but separate research enterprise from what we've done so far. This really is just the beginning. If you were to come up with mappings of Seymour's outputs to how many units of which type of toxin to put in which portions of which muscles, especially in the neck, where there's some complexity in terms of superficial and deep muscles, that's not a trivial effort, but it should be doable. Yeah.
Yeah. We have a question about the funding. So will you just, could you summarize for us sort of how the DoD funding worked? How long was it for? Are you still being funded through the DoD? Those kinds of things. I think our advocates are really interested in that.
Sure. There are several different mechanisms that they have. Like I alluded to at the beginning, this is called the Investigator-Initiated Research Award. This mechanism, I think, is nominally for 3 or 4 years. And we're in the 4th year on this, so we're approaching the end of this. And they have other mechanisms. There's a discovery award mechanism that I think is designed to be 1.5 to 2 years. There are larger programmatic programs that might be 3 or 4 or more, but I think 3 or 4 is probably the most common for this mechanism.
Yeah, and were you able to carry it over? Were you able to get like a no-cost extension?
Yeah, fortunately, and that's pretty common with most of these sponsors, and yes, with this one we did.
Yeah, great. Interesting question. Wanting to know if through this work anybody's diagnosis has been changed.
That's a great question. The short answer is no. But the more convoluted, realistic answer is, I think that sometimes that becomes suspect. I'll take the case of the laryngeal dystonia, for example. In our work with that the past 1.5 years, even to a lay person's ear, as well as experts that we collaborate with up at UCLA, Jerry Burke and A.B. Mendelson, some of the patients that, based on the clinical data, should have been diagnosed as not having voice tremor, definitely have some voice tremor. So, as with any data set, you'll always have things that are either, some you could have some minor errors for whatever reason, or, especially in the field of laryngeal dystonia, the specific diagnoses, even the experts in that field really have a hard time coming to agreement or consensus.
Yeah.
So it may not be a question of inaccurate diagnosis so much as providing an objective complement to help arbitrate cases where it's ambiguous.
Yeah, sure. Would you give us what CMOR is an acronym for? Just repeat that again.
Right. Computational Motor Objective Rater.
Okay, great. Thank you. And has CMOR been used to evaluate the benefits of physical therapy?
No, that's a good question, but it's general purpose in the sense, like I alluded to earlier, that you could take any measure of severity and use it as a before and after, whether it's toxin injections or physical therapy or what have you. So there's no reason it couldn't be used in that application.
Yeah. We have a number of questions that I think we probably need to, they're sort of more medically oriented, that we'll certainly try to get folks answers to. But somebody was commenting that, wearing a mask has sort of helped their cervical dystonia. It's almost, the mask has sort of served as a sensory trick. Oddly enough, so there was a benefit to wearing masks over and above keeping you safe from COVID. So that's always nice to know as well.
Yeah.
And then just, are there plans or are there discussions about using this as it relates to future treatments? We've talked about botulinum neurotoxins that are currently approved for cervical dystonia. What about using this as it relates to future trials for new treatments?
Yeah, We are in the process of working with a drug company that's doing some early testing of some new treatments for dystonia. And I think I can't go into the details, but that kind of thought process is underway.
Yeah, great.
And I was excited because I was excited about what they're doing, and they were excited to have an objective measure to complement the doctor's assessments. So I think
that's exciting as well.
Yeah.
You know, great. So again, we have a number of questions that are just more medically oriented, Dr. Peterson. So we'll again try to get those folks responses to those questions. I would just like to thank you again for your time in preparing this presentation tonight. It's really wonderful. Also, a huge shout out to our advocates. You know, as Carol said at the opening of tonight's session, dystonia advocates, it works. Our advocacy works, and we know it works. And it's a powerful way for us to provide opportunities for researchers like Dr. Peterson to apply for those funds. There are no guarantees, of course, but if we're not on the list with the Department of Defense, you're not even given the opportunity to apply. So the advocacy program is a year-long program. So if you haven't registered yet, please think about it. We'd love to have you as a part of this collaborative effort. And representing the needs of the dystonia community. So thank you all for your consideration. Dr. Peterson, thank you again for a wonderful presentation. Carol, thank you for your leadership with the Dystonia Advocacy Network. And I wish you all a good night and good health. Thank you.
Thank you.